In this video, I'm going to explain you about the Lewis dot structures. A Lewis dot structure is a very simplified representation of the valence shell, electrons, in an atom or molecule. It does not attempt to explain the geometry of molecules, but the knowledge of Lewis structure can help us to understand how the atoms will bond, how many bonds it will form, and it also helps us to understand the shapes of molecules and their chemical properties. Before going in detail, I would like to tell you that in whole of these slides, I would like to take a sphere as the nucleus with positive sign inside it and circular shells in which the electrons will be revolving. So for writing the Lewis dot structure, we need to know about the electronic configuration and the arrangement of electrons in different shells of atoms. So we'll try to write for the first 20 elements. Here we'll represent the nucleus as a sphere with positive sign, indicating that protons are present inside the nucleus and electrons will be revolving around the nucleus in different shells. So these electrons I have taken as a small spheres and the nucleus as a larger sphere. See, this is the nucleus with positive sign inside it. And these are the shells. 1, 2. Here I have taken 2 shells. So such other shells will also be there. And electrons are revolving around the nucleus. So in the first shell, 2 electrons are revolving, and in the second shell, 1 electron is revolving. This shell is called as a valence shell, and the electron that is present in the shell is called as a valence electron. In order to write or in order to draw the Lewis dot structure, we need to know how many electrons are present in the valence shell, otherwise the outermost shell. The electrons that are present in the outermost shell, called as valence electrons, in an atom of an element is depicted in a short form notation that is called as a Lewis dot structure or Lewis symbol. Now we'll try to let us try to write the dot structures. The first element is hydrogen. So hydrogen atomic number is 1. Its symbol is H. The electronic configuration for hydrogen is 1s1. It has only one shell which has 1 electron. This is the nucleus and this is the shell. In this shell it has 1 electron. This electron is called as a valence electron and this shell is called as a valence shell. Electrons in the outermost shell for hydrogen is 1. Now we'll write the dot structure. This is the nucleus and this is the valence electron. The next element is helium. Helium atomic number is 2. Its symbol is He. And the electronic configuration for helium is 1s2. So it has 2 electrons. This is the helium nucleus. This is the shell. So these are the 2 electrons revolving around the nucleus. So we'll take these 2 electrons and write the dot structure. These electrons are called as a valence electrons. Valence electrons is equal to 2. This is the helium nucleus. These are the 2 valence electrons. Let us write the dot structure for the third element. The third element is lithium. Its atomic number is 3. The electronic configuration for lithium is 1s2, 2s1. So lithium has 2 shells. This is the lithium nucleus. These are the 2 shells. In the first shell 2 electrons, and in the second shell 1 electron is present. This electron is called as a valence electron. Now we'll take this electron and write the dot structure. Valence electrons for lithium is only 1. This is the lithium nucleus, and this is the valence electron. This is the notation, Lewis notation for lithium. Now we'll move for the fourth element. That is the fourth element, beryllium. Atomic number is 4. Its symbol is Be. Its electronic configuration is 1s2, 2s2. So this is the sphere. First shell, second shell. So first shell 2 electrons are present. In the second shell 2 electrons are present. So this second shell is the valence shell, and these 2 electrons are called as a valence electrons. So electrons in the outermost shell is 2. Now we'll write the dot structure. Say this is the nucleus, and these are the 2 valence electrons which are blue in color. So 1 and 2, here 1 and 2 with opposite spin. Likewise we go for the next element, fifth element. The fifth element, boron atomic number is 5. Its symbol is B. Electronic configuration for boron is 1s2, 2s2, 2p1. 1s2, 2s2, 2p1. This is the nucleus. These are the 2 shells. first shell 2 electrons, second shell it has 3 electrons, 2 plus 1 3, 1 2 and 3. So we'll write the dot structure taking these 3 electrons, which are called as the valence electrons. Valence electrons for boron are 3. This is the boron nucleus. These are the 3 valence electrons. Let us see for the next element.
The next element is carbon. Its atomic number is 6. Its symbol is C. Its electronic configuration is 1s2, 2s2, 2p2. So this second shell contains 4 electrons and the first shell contains 2 electrons. So this is the sphere. First shell, second shell. First shell contains 2 electrons. So these are the 2 electrons. Second shell contains 2 plus 2, 4 electrons. 1, 2, 3 and 4. This shell is the valence shell and the electrons that are present in the valence shell are 4. Outermost shell contains 4 electrons. So we'll take these 4 electrons for writing the dot structure. Valence electrons equal to 4. Sphere. This is the carbon. And these are the 4 electrons, 1, 2, 3 and 4, 1, 2, 3 and 4. So here 2s2, 2 electrons, 2p2, 2 electrons, altogether 4 electrons are present in the second shell, that is the outermost shell. So here we have represented the 4 electrons, valence electrons. The next element is nitrogen.
The seventh element is nitrogen. So nitrogen atomic number is 7. Its symbol is N. The electronic configuration for nitrogen is 1s2, 2s2, 2p3. Here first shell contains 2 electrons and second shell contains 2 plus 3, 5 electrons. This is the nitrogen nucleus. This is the first shell, this is the second shell. First shell 2 electrons. Second shell 2 plus 3, altogether 5 electrons are present. So number of electrons in the outermost shell are 5. So number of valence electron is equal to 5. This is the nucleus, nitrogen. These are the 5 electrons. Here 2s2, 2p3. So 2 plus 3, 5. 1, 2, 3, 4, 5. Now we'll write the dot structure for the next element. Oxygen is the next element. Its atomic number is 8 and its symbol is O. Now we'll write the electronic configuration for oxygen. It is 1s2, 2s2, 2p4. So oxygen has two shells. First shell it is having 2 electrons and second shell it is having 6 electrons. This is the oxygen nucleus, and this is the first shell and this is the second shell. So first shell it is having 2 electrons and second shell it has 2 plus 4, 6 electrons. 1, 2, 3, 4, 5 and 6. Now we'll write the dot structure. Oxygen in its outermost shell it has 6 electrons, which we call them as the valence electrons. This is the oxygen nucleus, and these are the 6 electrons which we have taken as the valence electrons. Now we'll go for the next element.
The ninth element is fluorine. Atomic number 9, element is fluorine, its symbol is F. Its electronic configuration is 1s2, 2s2, 2p5. In the second shell it is containing 2 plus 5, 7 electrons. So those 7 electrons are the valence electrons. Let us see. Sphere, first shell, second shell. 2 electrons in the first shell. 7 electrons, 1, 2, 3, 4, 5, 6 and 7 electrons are present in the valence shell. Those are called as a valence electrons. 7 electrons are there. Now we'll write the dot structure. 7 electrons. Sphere with 7 electrons. 1, 2, 3, 4, 5, 6 and 7 with opposite spin.
The 10th element is neon. It is also called as inert gas or noble gas. Its symbol is Ne. Its electronic configuration is 1s2, 2s2, 2p6. See here, second shell it contains 2 electrons in S and 6 electrons in P. Total 2 plus 6, 8 electrons. 8 electrons it is also called as octet. This is the nucleus. First shell, second shell. First shell contains 2 electrons. Second shell contains 8 electrons. 2 plus 6, 8. So neon has octet in its valence shell. Every element tries to attain the octet, otherwise noble gas configuration to attain the stability. Now we'll write the dot structure for neon. Electrons in the outermost shell are 8, which are also called as valence electrons. This is the neon nucleus with 8 electrons in its outermost shell. The next element of the neon is sodium. Its atomic number is 11 and its symbol is Na. It has the electronic configuration 1s2, 2s2, 2p6, 3s1. So third shell has started from sodium. In the third shell it has 1 electron. This is the sodium nucleus and these are the 3 shells. So from sodium onwards, we'll see the third shell also. First shell, it has 2 electrons. Second shell, 2 plus 6, 8 electrons. And in the third shell, we have 1 electron. So for the Lewis dot structure, third shell is the valence shell, which contains 1 electron. Let us try to draw the dot structure. Valence electrons for sodium is equal to 1. This is the sodium nucleus with 1 electron. So the sodium has 1 valence electron, which we can take it to represent the dot structure. Let us see the 12th element. The 12th element is magnesium. Atomic number for magnesium is 12. Its symbol is Mg, and the configuration for magnesium is 1s2, 2s2, 2p6, 3s2. So S shell is completely fit. That the third shell in S orbital, 2 electrons are present. So this is the valence shell for magnesium. This is the nucleus. These are the 3 shells. First shell, 2 electrons are there. Second shell, 2s2, 2p6, 8 electrons are present. And in the third shell, it has 2 electrons. These are the valence electrons. Valence electrons for magnesium is equal to 2. This is the nucleus. These are the 2 electrons. Outermost shell, 2 electrons. Here, in the configuration, we see 3s2. Now we look for the 13th element. Thirteenth element is aluminium. Its symbol is Al. The electronic configuration for aluminium is 1s2, 2s2, 2p6, 3s2, 3p1. So here the p orbital has started. Third shell, the s orbital has completely filled, and here p is having 1. 3s2, 3p1. So both of them, they belong to the third shell. So third shell is the valence shell for aluminium. This is the aluminium nucleus. These are the 3 shells. First shell, 1s2, 2 electrons, 2s2, 2p6, that is 2 plus 6, 8 electrons. And in the third shell, 2 plus 1, 3 electrons are present. For aluminium, electrons in the outermost shell are 3, which are called as a valence electrons. Now we'll write the dot structure for aluminium. Aluminium nucleus with 3 electrons, which are the valence electrons, 3s2, 3p1, 1, 2 and 3. Now we'll see the 14th element, which is silicon. Silicon atomic number is 14. The symbol for silicon is Si. It has the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p2. Third shell, it contains 4 electrons. Now we'll write these 4 electrons for the dot structures. This is the nucleus, silicon nucleus. First, second and third shell, 1, 2 and 3. 3 shells are there. These are the 2 electrons in the first shell. These are the 8 electrons in the second shell. And these are the 4 electrons, 2 plus 2, 4 electrons in the third shell. Silicon has 4 electrons in its valence shell. Now we'll write the dot structure for the silicon with 4 electrons. This is the silicon nucleus. These are the 4 valence electrons, 3s2, 3p2. The next element is phosphorus. Phosphorus has atomic number 15. Its symbol is P. And the configuration for phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. 2 plus 3, 5 electrons are present in its outermost shell, which is the third shell. This is the phosphorus nucleus. These are the 3 shells. First shell 2 electrons, second shell 8 electrons, and third shell 5 electrons are present. 1, 2, 3, 4, 5. Phosphorus, which has 5 electrons in its outermost shell. Now we'll write the dot structure with those electrons. This is the phosphorus nucleus. These are the 5 electrons, which are called as valence electrons. So this is the Lewis notation for phosphorus. Let us see the next element. Sulfur is the next element with atomic number 16 and symbol S. The electronic configuration for sulfur is 1s2, 2s2, 2p6, 3s2, 3p4. This is the sulfur nucleus. These are the 3 shells. First shell 2 electrons. Second shell 2 plus 6, 8 electrons. Third shell 2 plus 4, 6 electrons. The filling of the electrons in the different shells is similar to that which we have done previously. So sulfur is having 6 electrons in its outermost shell. Now we'll take these 6 electrons and try to draw the dot structure. Valence electrons for sulfur is equal to 6. This is the sulfur nucleus. And these are the 6 electrons, that is 3s2, 3p4. Now let us see the next element. The, el the element with atomic number 17 is chlorine. Its symbol is Cl. Now we'll write the electronic configuration for chlorine. It is 1s2, 2s2, 2p6, 3s2, 3p5. Chlorine is having 7 electrons in its outermost shell. This is the chlorine nucleus. And these are the 3 shells. First shell, it is having 2 electrons. Second shell, it has 8 electrons. Third shell, it has 7 electrons. So chlorine has 7 electrons in its valence shell. The electrons present in the outermost shell or valence shell are 7. Now we'll write the dot structure for chlorine. This is the chlorine nucleus, and these are the 7 valence electrons which we have taken to write the Lewis dot structure. Now we'll see the next element. The next element is argon, which is the third element among the noble gases. Its atomic number is 18 and its symbol is Ar. And the configuration for argon is 1s2, 2s2, 2p6, 3s2, 3p6. See, all the noble gases except helium have octet in their valence shell. This is the third shell for argon. Third shell is the valence shell for argon, which has 8 electrons. This is the nucleus. These are the 3 shells. First shell, it is having 2 electrons. Second shell, it has 8 electrons. And in the third shell also we are seeing 8 electrons. So argon has 8 electrons in its valence shell, and these 8 electrons are called as octet. We'll write the dot structure for argon with the 8 electrons. Valence electrons for argon is equal to 8. This is the nucleus, and these are the 8 electrons. These are the valence electrons of argon. So all the noble gases except helium will have the S2P6 configuration in their outermost shell. Now we'll go for the next element. The 19th element is potassium. Its symbol is K. The kalium is the Latin name for potassium. And the electronic configuration for potassium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So from here onwards, fourth shell has started. So fourth shell is the last shell for the potassium, which contains 1 electron. This is the potassium nucleus. We'll see 4 shells, 1, 2, 3, 4. First shell, it is having 2 electrons. Second shell, 2 plus 6, 8. And in the third shell also we'll see 8 electrons. Fourth shell, it has 1 electron. So this is the valence electron. The electrons that are present in the outermost shell for potassium is only 1. Now we'll write the dot structure for potassium. Valence electrons is equal to 1. This is the potassium nucleus with only 1 electron in its outermost shell. This is the dot structure for potassium. Now we'll see the 20th element. Calcium is the 20th element, which has the symbol Ca. It has the configuration, that is electronic configuration, as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So it has 2 electrons in its outermost shell. Fourth shell is the valence shell for calcium. This is the nucleus, calcium nucleus, with 4 shells, 1, 2, 3 and 4. The first shell, it is having 2 electrons. Second shell, it has 8 electrons. Third shell is also having the same 8 electrons in its third shell. And in the fourth shell, you'll see 2 electrons. The number of electrons in the outermost shell for calcium are 2, 1 and 2. Let us try to draw the dot structure for calcium. The number of valence electrons are 2, 1, 2, blue in color. This is the calcium nucleus, and these are the 2 valence electrons. So in this way, we can write the dot structures for the elements as well as for the molecules also by taking the valence electrons. Thank you.